Hi ladies, this is chapter 6 and this is the first lesson in chapter 6, and in this chapter we're exploring rational exponents and radical functions. So we're going to go beyond just the polynomial functions we've looked at, and we're going to see some similarities between these two types, polynomial and any rational exponent functions and radical functions. But to start, we're going to look at nth roots and using rational exponents. So in this lesson, we're evaluating nth roots, and we're looking at the exponents, those rational exponents of a function. So first, your first vocab term is nth root of a. And the nth root of a you're going to see written similar to what you would see a square root written as, except that you see that n that is part of the radical. And that's the same as saying a to the 1 over n power. So again, previously we just worked with square roots. So if we had just the square root of a, we would say a to the 1/2 power. But now we're looking at the nth root, and we're saying that n is any positive integer that's greater than 1. So if we're looking at any positive integer that's greater than 1, it could be like the 5th root of a, and that's how you would say it. The 5th root of a equals a to the 1/5 power. So for any positive integer n that's greater than 1, we can take a root of a. If there's no root listed, like in this first example, no n value is listed, we're assuming that the root is 2, which is the square root. So let's look at this nth root of a key concept. So we're saying if n is an even integer, then a is less than 0. There are no real nth roots. So for example, if we're taking like the square root, we'll just use square root as our even root, for example. The square root of negative 25 is plus or minus 5i. That is not a real root. If we're saying a is equal to 0, then we're looking at the nth root of a, the square root of 0. 0 times 0 is 0. And then if we're looking at the nth root of a positive number, where n is an even integer, we're looking at the square root of 25. And that gives us 2 real solutions. And that's plus or minus 5, which is 25 to the 1/5 power. To the 1/2 power. Now, if n is an odd integer, then an a is less than 0. Let's look at the cubed root of negative 125. That's negative 5 times negative 5 times negative 5. So we have 1 real nth root. We cannot have positive 5. It's not plus or minus 5. It's just negative 5, because a negative times a negative times a negative is a negative number. Now, again, if a is equal to 0, we're looking at the cubed root of 0, and that's 0 times 0 times 0, which is 0. And then if a is a positive number, and our n is odd, we could look at the cubed root of 125, which is just 5, positive 5, times positive 5, times positive 5. So our solution would be 5. So that's just one real root. So let's look at applying this. So in this next example, n is equal to 3 and a is equal to negative 64. So we're looking at the cubed root of negative 64. Okay, so our n is odd. And our a is less than 0. So we know that we're going to have one real n root. And so we're looking for some number times itself 3 times to equal negative 64. We know it has to be a negative number. So negative 4 times negative 4 times negative 4. We know it has to be a negative number because a negative times a negative times a negative will give us a negative. It can't be a positive number because positive times positive times positive is still positive. So it has to be a negative number. So the nth root of a which is the cubed root of negative 64 equals negative 4. Now let's look at the second example where n is 6 and a is 729. We're looking at the 6th root of 729, which is the same as 729 to the 1/6 power. Now we know our n is even. And we know our a is greater than 0. So we have 2 real nth roots. Now you could do some guess and check, or you could use your graphing calculator, or any calculator that you can put in exponents. But something you should remember with your graphing calculator is it's probably only going to give you the positive solution. So you have to know that there are 2 real nth roots. So if you take 729 to the 1/6 power, it will give you just a solution of 3. But since a is greater than 0 and n is even, your actual solutions are plus or minus 3. Okay, so you could have negative 3 times negative 3 that will give you 729, or you could have positive 3. So either one of those are going to give you 729. So if you have 2 solutions, make sure you include both solutions. Try these next 2 examples on your own. You can pause the video while you work, and then when you're finished, you can unpause for the solution. So in this first example, our n is even and our a is greater than 0. So we know that we have 2 real nth roots. So we're taking the 4th root of 256, which is positive or negative 4. And then in our second example, our a is positive, it's greater than 0, and our n is odd. So we're taking the cubed root of 512, or 512 to the 1/3 power. We could only have a solution of positive 8. negative 8 times negative 8 times negative 8 will give us a negative 512, and we're looking for the cubed root of positive 512. All right, in this next key concept, we're looking at a to the 1 over n for it to be an nth root of a. And then we're looking at m as a positive integer. So when we write rational exponents, it does not always have to be in the form 1 over n. We could say any other rational numbers. So a couple examples, we could use 3 over 2. That's a rational number. We could use negative 1/2. That's a rational number. But our n is going to stay positive, and it's going to stay greater than 1. So let's look at this first example. So a to the m over n. That's the same as saying a to the 1 over n times m. So think of your rules of exponents. And that's also the same as saying the nth root of a to the m power. When you do this, when you simplify this, you would want to make sure that you do your roots first. And that's part of your order of operations. You do what's in parentheses first. So you take the nth root of a, and then take the result of that to the m power. Now let's look at the second example. A to the negative m over n. That's the same as saying, because our n is positive and greater than 0, a to the 1 over m, a to the 1 over n to the negative m power. Again, remember your rules of exponents. That's 1 over a to the 1 over n, a to the 1 over n to the m power, which is equal to 1 over the nth root of a to the m power. And again, order of operations, do what's in parentheses first. So you need to do your root first. So let's look at your next example. Evaluate the expression with rational exponents. So in this example, we're evaluating 8 to the negative 4/3 power. So that's the same as saying 8 to the 1/3 power times negative 4, which is the same as saying 1 over 8 to the 1/3 power to the 4th power, which is the same as saying 1 over the cubed root of 8 to the 4th power. Order of operations says do parentheses first. So that's the same as 1 over 2 to the 4th, which is 1 over 16. this next problem, example 3, solve equations using nth roots. So again, we want to solve for x, which means that first, before we even do that, we have to follow order of operations to get x to the 6th power by itself. So we're going to divide both sides by 2. So we get x to the 6th power equals 729. So now in this problem, we have our n is 6, which is even, and our 729, which is our a, is greater than 0. That means we have 2 solutions. So we're looking at here the 6th root of x to the 6th equals the 6th root of 729. So we get x equals, we can say the 6th root of 729, or 729 to the 1/6 power. And again, we're looking for 2 answers. We know we're going to have a plus or a minus. So when you take 729 to the 1/6 power, you have 3 times 3 times 3 times 3 times 3. Or you could also have negative 3 to the 6th power. So x is either positive or negative 3. So again, remember, if your n is even and your a is greater than 0, you're going to have 2 solutions. Okay, so then let's look at this next one. X plus 4 cubed equals 12. This is the quantity that we're cubing. So we're going to take the cubed root of both sides. And we get x plus 4 equals the cubed root of 12. And in this case, our n is odd, and our a is greater than 0. So this means that we have 1 solution. And in this case, we're just going to round. So we're going to take x plus 4 that equals 12 to the 1/3 power, but as an exponent, 12 to the 1/3 power. So in just rounding, x plus 4 equals about 2.29. And then we can subtract 4 from both sides. So our x equals negative 1.71. X approximately equals negative 1.71. You cannot have it the other way because, I mean, you're not going to get negative 6.29 because x has to be positive. There's only one possible solution. Alright, then let's take a look at this word problem. And it's about animal population. It says the population P of a certain animal species after T months. So the population is P. T is measured in months. Is P equals C times 1.21 to the T over 3 power. And it says C is the initial population. So we're finding the population after 19 months. So T equals 19. If the initial population was 75. So all we're doing here is substituting in our values. So we're using this model. P equals C times 1.21 to the T over 3 power. And we're looking for population. So population C is 75 times 1.21 to the 19 over 3 power. So if we think of what this is actually asking, we're saying that P equals 75 times the cubed root of 1.21 to the 19th power. Okay, if you think of what the rules of exponents are, that's what we're looking at. So we have to do our roots first. So let's take the cubed root of 1.21. And 1.21, the cubed root of that, so that's 1.21 to the 1/3 power is approximately 1.07. We take that number to the 19th power. We get approximately 3.34. And then we have to multiply by 75. And we get about 250.8. Now the question is, what's the population of a certain animal species? So you can't have 250.8 animals. So in this case, you would round up. If it was 250.1, you would still round up. If it's asking you something like the minimum animals. So in this case, P approximately equals 250.82. Therefore, P approximately equals 251 animals, whatever the species is. All right, the next few, you should try those all on your own, and then you can pause the video while you work, and you can unpause for the solution. So in this first problem, your final answer should be 1/25. Negative 125 to the negative 2/3 power is like saying the cubed root of negative 125. To the negative 2 power, which is the same as saying 1 over the cubed root of negative 125 squared. So the cubed root of negative 125 is negative 5. So you're looking at that number, negative 5 squared, which is 25. Your answer is 1/25. In this next example, you're going to have two possible solutions because your n is even and your a is greater than 0. So you have y minus 3 equals the 4th root of 200. So that means y minus 3 equals positive or negative the 4th root of 200. So positive or negative 3.76 approximately. So y minus 3 equals 3.76 or y minus 3 equals negative 3.76. So your two solutions, y equals 6.76 or y equals negative 0.76. And then we'll look at this last problem. So first of all, our volume model is pi r squared times h divided by 3. So our volume is 25 equals pi r squared, which we don't know our r, we don't know our radius, and the height is 6, and that's all divided by 3. So we're going to start first, we're going to try to isolate r by multiplying both sides by 3 and dividing by 6 pi. So now we have an even exponent, and our a is greater than 0, so we're going to have two possible solutions. However, keep in mind in the context of this problem, we're looking for radius, which is a measurement. So our measurement cannot be a negative number. Anytime you measure something, it has to be a positive distance. Therefore, we are only going to have one possible solution. So if we take the square root of both sides, 3.98 is approximately 4, so the square root of 4 is 2 now. So our r to solve the problem could be positive or negative 2. However, again, we cannot have a negative radius because radius measures distance. So please jot down any questions or notes that you have, and we can go over any questions or problems next time I see you in class. Thank you.